Hello, this is Dr. Kishore Porate, Professor and Head, Department of Electrical Engineering, Priyadarshini College of Engineering, Nagpur. This video based on multiple choice question on extra high voltage AC transmission specifically deals with power handling capacity of transmission line. Question 1. As the transmission voltage increases, the volume of the conductor, option A, increases, B, decreases, C, will not change, D, will increase proportionately. The answer is option B, decreases, because as we increase the transmission voltage level, the current in the conductor decreases, which decreases the size of conductor, and hence the total volume of the conductor decreases. Question 2. The power transmission capacity of the transmission line is option A, proportional to the square of the operating voltage, B, inversely proportional to the voltage, C, proportional to the voltage, D, inversely proportional to the square of voltage. The answer is A, proportional to square of the operating voltage, as the equation of power transmission is E square by x into sine delta, where E is the voltage, x is the reactance of transmission line, and delta is the phase angle between sending end voltage and receiving end voltage. By keeping the sine delta and x constant, the power transmission is proportional to the square of the operating voltage. Question 3. The bundle conductors are preferred for EHV transmission line because option A, it is easy to fabricate thin conductors and combine them to make a bundle. Option B, overall inductance of the line is reduced, also reduces corona loss and radio interference. C, height of the tower is reduced and hence cheap transmission. D, fabrication of the conductor is cheap. The answer is option B, because as we used the bundle conductors, there is reduction in inductance, also affects on the reduction in corona loss and radio interference. Question 4. The percentage power loss is independent on option A, length of transmission line, B, resistance of transmission line, C, reactance of transmission line, D, phase angle between sending end, receiving end voltage. Answer is option A, that is length of transmission line, because the percentage power loss is given by the equation R by X into sine delta into 100, where R is the resistance of transmission line, X is the reactance of transmission line, and delta is the phase angle between sending end voltage and receiving end voltage. Question 5. One 750 kV line can normally carry as much power as 400 kV circuits for equal distance of transmission. Option A, 4, option B, 3, option C, 2, option D, 1. The correct answer is option A, because as the transmission voltage decreases, it requires more number of circuits. Power handling capacity of transmission line depends on option A, voltage, B, reactance, C, phase angle, D, all above. The answer is D, all above, because power handling capacity is given by the equation E square by X into sine delta. So it is depends on voltage, reactance and phase angle. Question 7. One 1200 kV circuit can carry the power of 750 kV circuits. Option A 2, option B 5, option C 3, option D 6. Correct answer is option C, that is 3. The reason is, as transmission voltage level decreases, it requires more number of circuits. Question 8. What is the effect of extra high voltage transmission on power loss? Power loss decreases, power loss increases, power loss constant, any other. The correct answer is option A, that is power loss decreases, because as the transmission voltage increases, the current in the transmission line decreases and hence the power loss decreases. Question 9. Purpose of intermediate receiving station in power transmission is option A, to boost up current, option B, to boost up power, option C, to boost up voltage, option D, to boost up all above. Answer is option C, because intermediate receiving stations are required to boost up the voltage, as there is a voltage drop in the conductors. So to maintain the voltage, there is a need of intermediate receiving stations. Question 10. Number of circuits of transmission line can be reduced by increasing option A, energy, B, power, C, current, D, voltage. Answer is option D, that is voltage. As we increase the voltage level, the number of circuits gets reduced. Question 11. In transmission of power, voltage level is selected on the basis of option A, how much power is transferred for a distance, option B, on the basis of distance only, C, on the basis of power only, D, on the basis of environmental conditions. The answer is A, that is how much power is transferred for a distance. The voltage level is always depends on how much power is transferred for a how much distance. Question 12. Transmission line losses caused by option A, I square R heating of the conductors, B, I square X, C, I square Z, D, any other. Answer is option A, that is I square R heating of the conductors. So transmission line losses always depends on the square of current and the resistance of transmission line. Question 13. From consideration of power transmission stability, phase angle between sending and receiving end voltage is limited to option A, about 0 degree, B, about 30 degree, C, about 60 degree, D, about 90 degree. The answer is option B, about 30 degree, because when the delta is 30 degree, that time the system stability is maximum. Question 14. The power handling capacity of line at a given voltage level decreases with sending end voltage, receiving end voltage, transmission line length, phase angle between sending end and receiving end voltage. The correct answer is option C, that is transmission line length. Question 15. Benefits of EHV-AC transmission are option A, reduce power loss, B, reduce number of circuits, C, reduce right of way, D, all above. The correct answer is option D, that is all above, because when the transmission occurs at extra high voltage, it reduces the power losses, it reduces number of circuits, reduces right of way. So the answer is option D, That is all above. Thank you very much.